Radiation is emitted so isotopes can become stable. There are 3 different particles emitted: alpha particles, beta particles, and gamma rays. This lab shows the effects of distance on radiation. It also shows the effects shielding has on these different forms of radiation.
The materials we use are the Geiger Muller Radiation detector counter, the laptop, alpha, beta, and gamma radiation samples, and lead, paper, and aluminum.
First, we placed one of the samples of the radioactive element on a dip and placed it to a predetermined distance between 1 and 5 centimeters. The sample was placed in front of the Geiger meter detector in order to find the total amount of radiation the element was giving off. Next, we applied the different variety of shielding material between the Geiger Muller detector and the radioactive element. We placed the radioactive elements at different distances and recorded the amount of radiation given off after shielding.
The results we obtained from this lab show many things. First, it shows how the farther away the distance is, the less radiation is being received. This can be seen with a slow decline of beta once we put it farther and farther away from the Geiger Muller radiation detector. Another observation that can be made is that when shielding the object, the radiation emitted tends to get smaller, especially with lead. Lead is one of the most productive things in shielding and blocking radiation. We read this in thomasnet.com. This can also be seen through beta. It starts at 1,719 counts per minute with no shielding and goes down to 4.5 counts per minute with lead shielding. However, there could be errors with our data that could have been caused by incorrectly placing the radioactive samples from the Geiger Muller radiation detector, also by putting them in the same place as before.